So hello everyone, I'm Gokul Sharma, the AI/ML guy of the team Nirvana, and we are working on the problem statement 1, which is Srtk, the synthetic spot drug testing kit. So before I explain you our exact problem statement, our exact solution, let me give you a little context about what is spot testing, how it is being done, and why exactly it is being done. So we all are aware of the drug related challenges faced by our law enforcement agencies, by our police forces, by our border security forces, right? So whenever our law enforcement agencies they encounter a suspicious substance, which may be a controlled drug, they need a rapid preliminary indication of what they might be dealing with. So that's where the spot testing comes in. So instead of waiting only for the laboratory analysis, a presumptive chemical test is performed at or near the scene itself, right? So for example, we use a reagent such as Marcus reagent, which can produce characteristic color reactions with certain classes of the substance. So the traditional spot testing process is used basically for the speed and to get to know in what direction we need to take our investigation in, right? So with traditional process, it's very simple. You take the sample, you add the reagent, you observe the color, compare it with the reference chart, and that's it. The chemistry is easy and it's quite effective, but the problem is how we interpret and document that chemistry. So here are the two main problems: interpretation ki problem and documentation ki problem. First problem is of the interpretation की problem आती है because of the subjectivity, because of the biases, right? Because two people can look at the same color and they can describe it differently, right? One person can say okay this is dark purple, other can say okay this is violet, and this can change the uh, test results, right? And the result also depends on lighting conditions, reagent concentration, sample quality, sample quantity, and when is the reaction observed exactly, right? Because जो reaction है तुम्हारा, it can look one way after 5 seconds, and look the different way after 30 seconds. Because अगर तुम ग्राफ देख रहे हो मार्कस रिएजेंट का, तो इसमें ये टाइम के साथ चेंज हो रहा है, right? And the second main problem is of the documentation. Traditionally a lot of the information can end up being in manual records, meaning we don't have a necessarily a digital record of what the sample was tested, which reagent was used, what the reaction looked like, when it happened, and what exactly was observed. So we asked a simple question: can we modernize this process? Can we modernize this traditional spot drug testing का method without replacing the underlying chemistry? Because जैसे मैंने कहा, because it's the chemistry is incredible and efficient, and that's what Team Nirvana is building. We are developing a handheld portable spot testing device with a 3D printed enclosure for our MVP for this hackathon. The basic workflow is very simple. You put the sample inside the device, you add the reagent, and inside the device we are having two main things. This is very important. We are having a spectral sensor, the best in the market, AS7341, which is an 11 channel spectral sensor, by the way, which is way efficient than your traditional 3 channel sensors, which we could have used, but we went for the best one. As well as a camera, which allows us to capture the reaction through both sensor based and the visual based information. And then comes the brain of our device, which is a Raspberry Pi 4, where our analysis and logging pipeline will run. Then the user will select which reagent he or she used through our interface, because interpretation of color reaction depends on the reaction and the reagent involved. But here's where our approach becomes different. We don't want to simply make it a traditional spot test and say let's replace a human eye with a 300 rupees sensor. No, that would only digitize the existing process without really addressing the deeper limitations. We came to know about these deeper limitations through reading research papers. लाइक हमने एक रिसर्च पेपर पढ़ा एंड उसमें वी केम टू नो दैट द मोस्ट एफिशिएंट वे फॉर ड्रग स्पॉट टेस्टिंग वुड बी द काइनेटिक्स वे. मतलब वी are not going to read the colors, we are going to read the kinetics. So our team is doing this project, we are doing this problem statement, we are doing this solution in a research oriented way. We studied multiple research papers around drug spot testing, colorimetric detection and computer vision based analysis, and two major ideas from this research form the core of our solution. The first major innovation is our reaction kinetics. Instead of looking at the final color, we are capturing how the reaction changed over time. So we are not just asking what color did the reaction produce, we are asking how did the reaction involve. That gives us a much richer signal for our analysis. Second major innovation is of computer vision. This thing also we studied from the research papers that okay, we can implement this idea as well, है ना. हमें इस रिसर्च पेपर को भी लाइक रियल करना है ना. alongside with the AS7341 sensor we are using a camera to capture the visual characteristics of the reaction under a controlled environment. This gives us another source of information that can complement with the spectral sensor का data. And these aren't ideas that we simply invent out of the sake of adding कि हमें CV भी ऐड करना है, हमें ये भी ऐड करना है. All of these things that we are doing, they are approaches that are backed by existing research, and we are adapting those research directions into a practical handheld system. So our system essentially becomes सैंपल लिया आपने, रिएजेंट डाला, AS7341 सेंसर और कैमरा उसे सेंस कर रहा है, दैट्स आर सेंसिंग लेयर. रेस्पबेरी पाई 4 में वो गया, वहां से रिएक्शन काइनेटिक्स, कंप्यूटर विजन एंड एमएल ने अपना काम करा, एंड देयर यू आर गेटिंग अ preliminary interpretation, and then we are forming a completely digital record. The final digital record can contain the relevant information, evidence associated with the test, including the sample information, reagent use, sensor, camera observations, and reaction data, timestamps, and other relevant metadata. And all of that has to be cryptographically hashed. हमें उसके साथ जियो टैग्स लगाने हैं. And one more important thing, our system is not intended to replace confirmatory forensic laboratory analysis, वो जरूरी है अपने स्टेज पे, but we are designing to modernize the preliminary testing stage, making it more measurable, standardized, and portable, and digitally documentable. So that's the core idea behind Team Nirvana's synthetic spot drug testing kit. And for the rest of the presentation, we'll take you through how exactly we are implementing these ideas. We will be talking about all the innovations in the detail. We'll be talking about the system architecture. We'll be talking about the hardware layer. We'll be talking about the AI/ML layer. We'll be talking about the software layer. We'll be talking about what features we are bringing in, and we'll be concluding with our objective for this whole vision of a research oriented project. So let's get into it. Thank you.
So this is where our actual innovation comes in. At first, digitizing a spot test sounds pretty simple, right? We put a color sensor in a box, we wait for the reaction to finish, and then we take the reading. But then I thought, are we doing something really different? Because basically, we have just replaced the officer's eye with the sensor. We are still asking the same question: what color did it finally become? And we wanted to ask a better question, that is, what actually happened during the reaction? Because a chemical reaction is not just only one final color, it's basically a process that has occurred. Two different substances might end up looking almost the same at the end, but they might reach that color in completely different ways. One might change very quickly and then become stable, another might change slowly, and another might change quickly in the beginning and then gradually settle. So instead of taking just one snapshot, we decided to watch the whole reaction. So basically, we made a curve known as the kinetics curve. What it does is it checks that how the signal changes with time, how fast it changes, and where it stabilizes. And this gives us much more information than the final color. So you might think that where did the idea of kinetics curve come from? So basically, we read a research paper from University of Strathclyde in 2025 where computer vision was used to monitor color changes over time in presumptive drug testing. The important takeaway from the research was that the reaction itself contains information that is not just only about the final color, it is all about what happened during the reaction. And similar work has also been explored across different drug cases. Our second innovation is that we are not just relying on only one type of measurement. Here we are having spectral sensors as well as the camera. The spectral sensor is used to measure the qualitative information across multiple wavelengths, while the camera is used to measure the optical activity, that is, the change in texture, precipitations that are formed, cloudiness, etc. Now, why here we are using camera? Here we are using camera because there may be some visuals that may not be sensed through the spectral sensor.
So now let's talk about the hardware part of the project. So we are building this as a complete functional device rather than just a software prototype. We'll be having a camera for capturing the visual data of the samples, while the AS7341 spectral sensor will be capturing its spectral and color response थ्रू 11 चैनल वेवलेंथ्स, यानी कि वो 11 अलग अलग कलर्स को सेंस कर सकता है, विच विल बी very much precise and accurate, because that's the thing we are looking for in this project, right? And a Raspberry Pi 4 will act as a onboard processing unit which will be handling data logging, analytics, image processing and other system functions. And then we are also designing a custom PCB to integrate these products, these components, all these features into a compact and reliable system along with the 3D printed casing to properly house and align all the hardware. So from the camera and the spectral sensing to onboard analytics to custom electronics and final 3D printed enclosures, we are building the complete hardware pipeline for a real world functional usage.
सो जैसा कि मैं आपको एक्सप्लेन कर रहा था, हमारे प्रोजेक्ट में मेनली 3 पार्ट्स है. फर्स्ट इज द एम्बेडेड पार्ट, सेकंड इज द AIML पार्ट एंड थर्ड इज द सॉफ्टवेयर इंजीनियरिंग वाला पार्ट. एंड जो हमारे सेकंड पार्ट है AIML वाला पार्ट, दैट्स द मोस्ट इंपॉर्टेंट थिंग ऑफ आवर प्रोजेक्ट. बिकॉज जो डेटा आ रहा है सेंसर से, हमने सेंसर लगा दिया, हमने कैमरा लगा दिया, हम हमारे पास उससे कलर का डेटा आ गया, हमारे पास काइनेटिक का डेटा आ गया जिससे जो हम बनाएंगे. बट आगे क्या होगा? आगे AIML वाला जो पार्ट है उसमें क्या हो रहा है, ऑल ऑफ दैट 10 चैनल kinetic curve and the camera's visual signals, all of them will be getting fused into a single feature vector, and it will be fed to a classifier running right on our device, right on our Raspberry Pi 4, right? And we deliberately went with a lightweight feature based model instead of a deep neural network, because it works reliably even on a small training set, and it retrains in seconds when a new drug analog needs to be added, which is the best part. And this part matters a lot for forensic use because every result is explainable, and we can point to exactly which part of the curve drove a given classification, ताकि हम उसको अच्छे से explain कर सके and accuracy and precision को maintain कर सके. And instead of asking anyone to just trust a black box, we are bringing in a complete brain to our machine, which is reliable, which is precise, and which is accurate.
The moment a result comes out, the software layer takes over. It automatically captures the GPS location and timestamp, then generates a SHA-256 hash of the complete record, including the result, the raw curve data, and the location, creating a tamper-evident digital record. Everything is visible through a local dashboard that the officer can access from a phone, and each test can be exported as a structured evidence-grade PDF report. Here is the measured reaction, here is the how it was classified, here is the confidence, here is when and where it happened, and here is the record of the test. That is the digital chain of custody we are trying to create.
So, in the end, we are concluding our project by stating that with this project, with this research and everything, we are modernizing a 50-year-old method and not replacing it. We are bringing in everything that that method has been used for its speed, for its low cost, and for its field usability, and everything that had made that spot testing useful for decades. What we have added is the technology that should have been implemented years ago. We are bringing in precision and explanation for every result, and a record that can't be quietly changed after the fact, so that it can be reproduced in the courts easily. And we are Team Nirvana, and we think this is where our presumptive drug testing needs to go next, and we are taking it. Thank you.